Hello, tiny students. I'm Neha, and today I'll be covering a brief introduction of the chain rule. Now, what is the chain rule, and why do we want to learn about it? So far in this course, you've covered derivatives of simple functions like x squared, e to the x, trigonometric functions like sine x, tan x, etc. And how to differentiate the sums of these, products of these, quotient of these. But what happens and how do you find the derivative when you have a composite function? Maybe something like the square root of x squared plus 1 or e to the sine x, or maybe even cosine of x fourth plus x squared plus 4, or maybe even some crazier function. Now, you could use the limit definition, and fine, for some of them, some of the functions, that's doable. You'll get your answer. But for some of the more complicated functions, the limit definition will very quickly become unwieldy, and you won't be able to find an answer very quickly. So what do we do then? This is where the chain rule comes into place. The chain rule basically answers the question that if you have a function h of x, which is of the form f of g of x, which is f composed with g of x, the chain rule answers what is h prime of x. That is the question that we answer by using the chain rule. But before we get to that, we first need to be able to figure out, given such an h, what are f and g? So, for example, if we take the function x squared plus 1 as h of x, what are f and g? Here, f can be considered the outer function and g the inner function. So here, we have x squared plus 1 on the inside. G of x is x squared plus 1. F of x is square root of x. And if you evaluate f of g of x, which is f of x squared plus 1, which is square root of x squared plus 1, you exactly have what you started with, h of x. So now try and find what f and g would be for these two functions here. Now that you can figure out what f and g are given a particular h. What is the chain rule? Now, if we have a function h, which can be written as f composed with g, where f and g are good functions. And by good, we mean functions that we can differentiate in the given domains. We have that h prime of x is precisely if f prime of g of x times g prime of x. And what do we mean by this? Here, f prime is the derivative of f, but we're evaluating it at g of x and then multiplying it with the derivative of g. And going back to our original example, here we have f prime of x is 1 upon 2 square root of x. G prime of x is 2x. And g of x is, as we already have up here, x squared plus 1. So if we evaluate f prime of g of x, we have that it's 1 upon 2 square root of x squared plus 1. And hence, putting it all together, we get h prime of x is f prime of g of x, which is 1 upon 2 root x squared plus 1 times g prime of x, which is 2x. Here our 2's cancel, giving us x upon square root of x squared plus 1. So now you have a brief introduction of the chain rule, and I encourage you to go back and try to find the derivatives of these two functions. Thank you.